My name is Shavi and welcome to the 8th presentation of the Algebra 1 course. So, today is the session as per the instruction. From now onwards, first we shall go through assignments, and if time left, then only we go through the concepts or doubts from other questions. Okay. So, first today we start assignments from the ring theory portion. And from first we'll go through ring theory, then we'll go through group theory. Because ring theory has been done recently by that's so okay. So so let's start. So first question is let here be the power set of this, and for a comma b we define a plus b be the symmetric difference of a and that is we are defining a plus a and b. Intersection a. Let's multiply now. Question then PS is what? PS dot. I mean it's a ring, but the question is the following. Option A is not a ring. Option B is not a ring. Option D. And so first of all it's a ring. So first this option will not hold. Okay. So since it's a ring, so what is its identity? So it's zero elements. I mean zero elements and eight elements. Okay. So for integral we need to check that whether is no, because it is intersection is also. So it is not a really what is the intersection A is equal to A dot. Is the evidence the evidence yes, because if on the A dot A that is A dot A for all A subscripts. So this of 30 marks in the start. sure which is the correct option? Option. The correct option is okay. So okay. So let me. So P is given to the power set of A and B. Then we are defining A plus because we are defining as symmetric difference. Then A may be intersection A. I mean A dot is defined as A intersection. Now with respect to this operation, P S plus dot is a ring with the zero element is equal to 5. And 1 is the I whole set capital. First, it is a ring obviously. Then about the integral of word. So we need to check A dot B equal to 3 plus A equal to 0, B equal to word. Now A intersection B equal to empty if and only. I mean A intersection B empty. Sorry, it's not if and only. It's a part. It does not imply A equal to empty or B equal to empty. So it is not an integral. Now A dot is equal to A for all. So it's the so that's why A complex. That is S plus dot is a definition of it. So now the second problem. Second assignment problem. Curly is stage with P1. But let me guys open. So that's the first question. Am I audible?
Yes, yes, yes. You're audible and sound is slightly
Now tell me is
less.
the now yes okay now tell me is the sound fine?
1 minute. Hello.
Yes, yes.
Huh.
Is the
Say
sound
something, sir. Huh.
yeah is the sound fine right now?
Better,
Okay, 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 okay.
sir. Whatever I have done today, I have joined late.
That I am. Okay. So the thing is that as per sir requested, from now onwards, I shall first start with assignments. Okay, and if then time left, we'll then we revisit some concept or some doubts. Okay. First, we will go to some assignments. But also, since right now sir is doing ring theory part, so first we shall go through the ring theory assignment, and then we shall go back and do the group theory assignments. Okay. So today we are going to do the assignment 6, the ring theory assignment. Okay. Do you understand?
Yes, yes.
So one second. So the first problem. Okay. So the first problem. Okay. The thing is that since sir has told me to solve problems for assignment, that's why I am solving each and every problem of the assignment. Okay. So I mean thoroughly each and every problem of the assignment. Okay. So the first problem is that suppose PS is a power set of any set S. Then for any A and B, we are defining A plus B and A dot B as follows. A plus B is defined to be this and A dot B is defined to be this way. Now the question is as follows, that PS plus dot is it a ring or yeah, is it a ring or is it a non-unitary ring or is it a unitary ring or is it an integral domain? So that's the question you need to. I mean, so and it is a one answer correct. Sorry, it's the answer that question. So the thing is, obviously it is a ring. I hope you know this why it is a ring, right? And
Yes.
yes, okay. And this thing is a ring with the zero is the identity element. I mean, pi is the zero element, and the whole set capital is the identity element. Okay. And now also do note one thing that it is not an integral domain because a dot b equal to a intersection b equal to phi if and only if either a equal to phi or b equal to phi. I mean, for integral domain it should hold, right? But if we take some disjoint subsets of S, then in intersection is empty. So that's why it is not an integral domain. For the unitary ring case, we need to find it as a unit or not. Okay. Now A dot S is equal to A intersection S is equal to capital S. So S is the unit. Okay. So that's why only correct option is option C. That's the answer. Do you understand?
Yes, sir.
Okay. Okay. So the next problem is follow. So next problem is that a ring is said to Boolean ring if x square equal to x for every x. Okay. Now the true or false. The question is that every Boolean ring is commutative. So this is the question.
Okay, let's try.
Take it back. Any guess or any idea? So, okay, so everybody's comedy can be done as follows. So it is given that x square equal to x for all x belongs to G. Okay, so we can so this tells that 2x whole square equal to 2x. Okay, for all x. This implies x plus a whole square is equal to 2x. Okay, this implies what? X square plus x square plus 2x square is equal to 2x. Okay, this is equal to x. This is equal to x. So total 2x. So this implies 2x square equal to 0. But x square equal to, yeah. Hello. Hello.
Hello.
Yes, yes. So
Hmm.
okay. So I just have done it. Have you solved this problem partially? Okay. So let's see. So it's given that x square equal to x for all x in G. Okay. So this implies 2x whole square equal to 2x for all x in G. 2x can be written as x plus x whole square equal to 2x. So if we break it up, then x square plus 2x square. But x square equal to x square equal to x. So after all, we get 2x square equal to 0. This implies 2x equal to 0 because x square equal to x. Okay. So first of all, for a Boolean ring, 2x equal to 0 for all x in that ring R. Okay. Now, now take any two random elements. Okay. Then x plus y whole square equal to x plus y by definition, by the Boolean. This implies y square, x square plus y square plus xy plus yx equal to x plus y. X square equal to x, y square equal to y. So this implies xy plus yx equal to 0. Okay. So this implies xy plus yx. On right and left side we are adding one yx. Okay. This implies xy plus 2yx equal to yx. Now, in the definition of Boolean, I mean, from just now we got that 2x is 0. Okay, so this implies this thing is this, so this whole thing is 0. So this implies xy equal to xy is equal to yx. So that's why Boolean array is commutative. So this is the argument. Do you understand?
Yes, yes.
So uh, now the third question is which. So do you know the definition of integral domain? Do you know the definition of integral domain? Do you know the definition of integral domain? Okay, I hope you know this. Okay, so the question is which of the following is integral domain? First one is z by 2z. Second one is z by 3z. Third one is fourth one is z by 9z. Now check which one of these are integral domain. Okay, kindly check. So basically, in order to find whether something is integral domain or not, we need to check a b equal to 0 implies a equal to 0 or b equal to 0. If this happens, it's the integral domain, otherwise it's not the integral domain. Okay, that's what you want to need to check. So kindly check which of the following is the integral domain. That's all. So the person who has just joined now, okay, so let me repeat. Since I was requested to go through the assignment, so from now onwards, first we shall go through the previous assignment, and if there's been time left, then we shall review this concept. Okay. Also, since sir is right now doing a ring theory first, so first we'll go through the ring theory assignment, and then we'll come back and then go through the group theory assignment. Okay. Today we are going through the assignment 6, and we have already done the first and second problem. Right now we are doing the third problem. The third problem goes as follows: that which of the following is the integral domain? Z mod 2, Z mod 3, Z mod 6, Z mod 9. You need to calculate which one of these integral domain. Okay. So first do this, and for the fellow who has joined late, I shall go through the question 1 and 2 again. Okay. But kindly right now, please solve the question 3. Okay. So first tell me, do you know what is the integral domain? Do you know this? If you don't know, please tell me. Let's go.
Commutative ring with identity having no zero divisor called integral domain.
So now determine which of one of these integral domain.
Yes, here z by 2z integral domain, z by 3z integral domain, and z by 6z and 9z not integral domain.
Why?
Because if z by some pz where p is prime, then it must be integral domain.
Yes, okay. And why z by 6 that is not integral domain?
Huh?
Why z by 6z? Why z by 6z is not integral domain?
Because here mm, 3 into 2 mm, 3 into 2 6z is equal to 0, where 3 or 2z none of them are 0.
Fine, fine, fine. That's fine. Okay. So, okay, so for okay. So now the next question. What is that? Okay. So which of the following groups are integral domain? S6, D4. So the question is which one of the following groups are integral domain. So first of all, do note one thing here. Everything is group here. Okay? Which of the following group are integral domain? Group means you need to check A, B is equal to identity. Does it imply A is equal to identity or B equal to identity? Okay. If this false, then those groups are said to be integral domain. Okay. So now check that which within this tree which one of this is integral domain. Okay. So did you check S6? So whatever S6, can anyone can two of you can anyone tell me? S6 is an integral domain and not as a group.
S6 is non-commutative at first.
No. First of all, okay. So, what is the definition of integral domain? I mean, by definition, it is taken to be commutative, right?
Yes, yes.
Okay, so the thing is that uh, an integral domain means a b equal to 0 implies
Hmm.
either a equal to 0 or b equal to 0.
Or B
Okay,
equal to 0.
yeah,
Yes,
you
yes.
don't need to think about whether it is commutative or not. Okay, that's it. I mean, the commutativity is taken for some convenience. That's all. But in reality, the definition does not have any connection with the uh, commutativity. Okay, that's the point.
Okay.
Secondly, it's a group, not a ring. Okay, that's right. Think about it. What about the other person? Nivya. So what about Nivya? Can you tell whether S6 is a integral domain or not? Can you tell whether S6 is integral domain or not? Okay, so do note one thing. Okay, so let me tell you solution. So in S6, consider a six cycle. Okay, okay, six cycle completed. Consider a two cycle. Okay, suppose one two. Then one to the two cycles. So one two of compose one two is equal to identity, right? But individually one two. I mean individually it is not an. I mean individually one two is not an identity, right? So that's why A6 is not an integral domain. I mean, so exactly the same are going to work that Sn for any n is not an integral domain. So for Sn case, it is not the case. It is not integral domain. Do you understand for the Sn solution? I hope so. So now come with D4. What is D4? Yeah. So basically in D4 we have some reflection R. So the R square is equal to identity. But anyway, R itself is not an identity anyway, right? Because it's a reflection. So D4 is not an identity. I mean, sorry, it is not an integral domain. Now, what about Z? Now, in Z, AB equal to 0 implies A equal to 0 or B equal to 0. So, obviously, the integer Z is an integral domain. Okay, so that's the argument. Do you understand?
Yes, yes.
So, now, the next question is what? Let R be an integral domain. Okay. ID means integral domain. Then, matrix string over the into matrix string over R is an integral domain. It is a true or false. So the question is suppose R is an integral domain. Now consider the M2 or the matrix string over the integral domain. That is each element of the 2 plus matrix are an element of the string capital R. So now question think try to show or try to give counter argument counter example that M2R is an integral domain. So for that, what you need to do is, I mean, if you need to find a counter, first of all, is the matrix. Okay, so intuitively you can understand it is not integral. So you need to for that come up with two elements from M to R, which is individual non-zero or their product is zero. But do note one thing that the ring capital R is also integral domain. So try to construct such a counter example which tells that M to R is not an integral domain. I mean anyway, matrix can't be integral domain. That's the point. So that's the step. Anybody solved it? Has anyone done it? If in a partial progress, don't be silent. Okay. So, let's see how to solve this problem. First of all, take R to be the ring of integers. Okay. Then what is M to Z? It contains is the 2 cross 2 matrix whose all elements are from Z. Okay. Now do not consider these two matrices. Sorry. The multiplication is 0, 0, 0, 0, but none of them is 0. So that's why M to Z is not an integral. And the same argument works for any Mn of any integral domain. I mean, instead of any random integral domain, a particular integral domain, you can take in a random integral domain. The same example will work. Okay, that's the fact. So that's why matrix ring is can't never be an integral domain. So that's why okay. So for I mean, if you know the ring of quotients, so that's why usually the ring of quotients is studied usually over the integral domains. Okay, but since matrix ring is not a integral domain, so there is no concept of ring of quotients or ring of fractions uh, around the matrix ring. So that's why the study of matrix ring is somewhat different from the usual study of ring theory or commutative ring theory. Okay, and so indeed there is a separate subject called as non-commutative algebra, which particularly deals with matrix ring and their properties. Okay. So if you pursue some higher degree, then you will get to know about this non-commutative algebra and also. Okay. Next, next question is, so it's a true for question. Correct, the polynomial moment set is an Euclidean. So you need to check whether ZX is Euclidean domain or not. Okay. So first of all, anybody please tell, do you know the definition of Euclidean domain? If you don't know the definition, please tell. I will tell you the definition.
It is a integral domain with the conditions such that for A and B any two non-zero, B non-zero. So there is some unique R such that A is equal to BR plus some constant, some Q, where Q is where the metric, the distance metric uh, between distance metric of Q 0 to B minus 1.
Okay.
Mm, mm,
The only thing you know, right?
yes, yes.
Okay. So first tell me from where you have used the term distant metric. I mean, have you read it in from some book, or you just intuitively keep this thing in your mind?
Intuitively book.
Okay, then that's okay, no issue. Okay, so in the definition of Euclidean domain, there is two conditions. You you tell me only one condition. There is another one condition. Can you remember?
Mm,
Remember the other condition? So R is an integral domain. Okay, integral domain I will denote it by ID. Okay, so then R is said to be an equivalent domain if
mm,
there exists a mapping. I mean, there exists map from what to where, from R minus 0
uh,
to n union 0 such that V of A less than equal to V of AB for all AB inside R minus 0, and the second condition, for any AB inside R with V not equal to 0 there exists Q and R inside R. Okay, by the way, you told one thing that there exists unique R, okay, but the thing is
uh,
it may not be unique. I mean, it need not be unique, okay,
uh,
because I mean 6 can be written as 2 into 3, it can also be written as minus 2 into minus 3, right? So there is no, so I mean, so that's why there is no point of uniqueness, understand? So that's why there exists Q and R such that P is equal to A into Q. Q denotes for quotient, so that's why A into Q plus R. R denotes for remainder. Okay. Such that either R equal to 0 or V of R is less than V of what? And if, sorry, V of A. And if such a thing holds, then R is said to be equivalent domain. Okay, that's the definition. Understand? So now, so now tell that whether ZX is an Euclidean domain or not. Okay, so first of all, directly from definition is not possible. Okay, so
yes,
first,
yes,
first tell me, do you know any properties of equivalent domain, or do you have you read any theorems? Whatever you read, whatever you can remember, just tell me.
yes. Question. What you have told.
Well,
Yes. What you have told. I am clearly here.
so the thing is, in order to solve the question whether the ZX is an Euclidean domain or not, it
Yes, yes.
can't be directly solved from definition. Okay, for that you need to use some theorem. Okay, so my question is that, do you know, I mean, is any theorems related to Euclidean domain has been taught in class?
Yes.
So can you please tell what are those
Uh,
theorems?
yes, I am remembering the concept.
Yes, okay. Roughly you can, if you can roughly tell, then no problem. Don't think that you need to precisely recall the definition, recall the theorem. No, I mean, roughly you can tell, no issue.
Just yes. Um, I mean Euclidean domain imply it should be PID, principal ideal domain.
Okay,
Okay.
yes.
Okay. Yes. So we can construct ideal two which is generated by 2 and x, that is in Z, in
Yes,
ZX.
yes.
Uh, uh, mm, it can be shown that it is not generated by only single element of ZX. So it is not PID. So that's imply it is not ED.
Yeah, perfectly fine. So good, very nice. So why this ideal generator by x comma 2 can't be generated by single element? Any idea?
Mm,
If you have semi, if you can recall also you can tell. I mean, if you have a rough idea, then also you can tell. No issue. Whatever you in whatever thinking you are doing, just tell without any hesitation.
how I assured that this ideal should be taken in this form.
No, no, no. My question is why this ideal generated by x and 2 cannot
Mm.
be generated by a single element?
Okay, okay. Argument. Achha.
Yes.
On contrary, we can suppose it is generated by a single element. Say
Okay. Call it fx.
say so fx, yes, yes,
Then
fx. Then uh, uh,
tell us. Don't hesitate.
using Euclidean condition, we can write fx.
No, no, no,
Fx
no.
is,
Equivalent condition means, I mean, either z is equal to the fx, right? So then,
mm, mm,
first of all, note, note one thing that since zx is not an equivalent domain, so that equivalent argument will not work here. Okay.
oh, mm,
I mean, equivalent argument works only in equivalent domain. So here
uh,
we will not work. That's the first thing we clear.
okay, sir.
Okay. So now tell what are
Yes, uh, fx, we write x in term of fx. Uh, x is equal to some element of z into fx.
everything is inside zx. Okay, it is not z. I mean, you can
Mm,
write x equal to gx into fx, right?
yes, yes, yes.
Then
Then and two also some hx into fx.
yes,
Now if we consider the degree of the both side, to in case of 2 here, x degree of the x is 0. So so uh,
what degree? So sorry, sorry, what is degree of x? Zero you have to apply.
I mean 2 is a constant, so here a degree of uh, fx into hx must be hx into fx must be constant.
So first of all, degree of h into f is equal to degree h plus degree f, right? Correct.
Yes, yes.
Yes. So degree h plus degree f is equal to 0. Then
Mm. Then if if is a non-zero element, if ideal generated by fx, here if fx is not non-zero element must be. So hx, so hx should be 0. Mm,
And goes as follows. Since degree is 0, so anyway, the degree of f equal to 0, correct? Okay. Now, so f will be either 1 or f will be minus 1, correct?
minus 1, yes.
Yeah, because here we have only 2.
Hmm.
So, or I mean, plus 1 or minus 1 or plus 2 or minus 2. There are only these four possibilities of for the
Hmm.
capital F, right?
Hmm.
So now capital F, now the small f, can it be 1? Can it be 1? If
Hmm.
the small f is equal to 1, then ideal generated by
Or
f,
ideal, then whole
yeah,
ideal generated by apex turns into be whole zx if
yes,
it is
yes,
1.
yes, that's not possible. So that's why the fx can't be 1, and the same reason that fx can't be minus 1, right?
Yes, yes.
Okay. Now, what about the can fx uh, be 2?
Apex 2, if apex is 2, then g, then by other condition x is equal to gx into fx, so gx would be linear. Oh, it maybe 2.
No, no. I mean, if f is 2, then if f is 2, then ideal generated by fx. I mean, ideal generated by fx. All elements. I mean, any polynomial in that ideal. All coefficients are even coefficients, right?
Yes, yes,
But in ideal generated by x comma 2, this is not the case. I mean, in ideal generated by x comma 2, the polynomial x is there. Its coefficient is order, right? So that's why fx can't be 2. You understand?
yes, sir. Please repeat the logic.
Yes, yes. If f equal to 2,
Oh,
if
oh,
equal to 2, that is an ideal generated by x comma 2 is equal to 2zx, right?
yes, yes.
So that is if we take any random element,
Hmm.
I mean, so any polynomial in ideal generated by x comma 2, if each of the coefficient is even, correct?
Hmm, hmm, yes,
But ideal generated by x comma 2 contains the polynomial small x also, right?
yes, yes.
The coefficient of x is 1, which is not even, right?
Yes, sir.
Yeah, so that's why either generated by z x comma 2 is not a cannot generate a single level. That's why zx is not PID. That's why zx
Yes.
is not an ED. Okay, understand?
Okay, okay.
So yeah. So now, so so now the next question is as follows: uh, let the degree function d of an Euclidean domain R called multiplicative if d of AB is equal to d of A, d of B for all AB belongs to R, and B is a strictly positive function. Okay. Now question is given a unit U inside R, what are all possible values of U? That's the question. So let the question get to the question. Degree for an equivalent domain R, the degree function D is given. Okay. The degree function, or I have written that it's a function C. Same thing. Okay. This degree function is said to multiplicative if satisfy the multiplication rule. And the degree function is given to be strictly positive. Okay. Now
ఎప్పుడు ఎక్కడ నీకే పెట్టా నీకే పెడతా
So, so the question is that if DAB is equal to DA into DB for all AB belongs to R and D is say given to be strictly positive, now the question is for any given unit U in R, what are the all possible values of D of U? Okay, so this is the question. Now think about it. Do note one thing that D is already a degree function, so D has some properties from the equivalent domain from the according to equivalent domain definition, and also it is given to be multiplicative in nature. Okay. Now think about it. What is the all possible values of D? Okay. Okay. The answers. I mean the options given follow: A equal to 0, 1, C is infinity, D is insufficient answer. But anyway, you need to calculate what is the question. How do you calculate D? You need to make use of the properties of D that come from the equivalent domain. Also, you need to use the multiple. Okay. So please try.
Sir, is it 0?
Why?
Because if we you have given that U is the unit,
Yes.
so U inverse is equal to identity. Yes, if we consider D of U inverse is equal to 0,
Why? Why?
why?
One is just a unit. That's all. You don't. Nobody has any information about what is D1. So I mean, D1 need not be zero. I mean, don't we don't have any information regarding that, right?
Yes,
Okay, just tell me one thing. Okay, load it. Okay, the thing is that from the given relation D, AB is equal to DA is to DB, from that relation, first you need to find out D of 1. Okay,
Yes, yes.
yes. So, first tell what is D of 1 then. Tell what is first the D of 1.
And D of 1 is greater than D of U.
No, no, what I have said. I have said that D of AB is equal to DA into DB. From this relation, you need to find the D of 1 exactly. Okay. So, I mean, you need to get D1 from the given equality. So, what do you need to do?
We have I am using the first condition of the Euclidean domain U of A less equal to
Is
U of
okay.
AB, where AB belongs to
Wait,
R.
okay, that is okay. But the thing is, what I'm saying is that first, from the given multiplicative relation, you
Hmm.
need to calculate, you need to find out the value
Okay,
of D1. Okay, so
okay,
first,
okay, okay. Oh, sorry,
yes,
sorry.
yes, no, yeah. So first tell what is the value of D1. In that relation, from the relation, what you need to do in order to get the D1. In that relation, from that relation, how will get D1?
Oh, sorry, sorry, sorry. D1. Oh, sorry. D of one. D of one is equal to D of D square one. So D of one is equal to either 0 or 1.
Yes. So now,
Uh,
what will be D1?
yeah. Now,
So
if
what is so
D1,
what will be D1? It will be either 0 or 1. Then what is
yes,
what is the exact value of D1?
then D of condition. Yes.
You already mentioned the question with one
Uh,
property. So what is the value of D1?
D1 greater equal to 0.
Then clearly that is strictly positive, right?
Yes,
So
yes,
D of 1 is equal to 1, first of all.
yes.
Okay.
Okay.
Now, yeah, now use the properties from the Euclidean domain definition
Hmm, hmm,
in order to get the value of dq. Okay.
hmm.
Now, in the whatever you are trying to say at that moment, you impossible one. Now use these things and the properties of the Euclidean domain for the definition.
d of 1 greater than equal to
Yeah,
d of u.
this is one side. Okay, so d of u is less than next.
Next,
The next is
similarly d of u inverse less than 1 8
when u inverse equal to 1, so does the given 1 can be written as 1 dot, sorry, I mean d of 1, by definition it is less than equal to d of 1 dot u, right, which is nothing but d of u, correct?
yes, so d of u is equal to
Yeah, so d of u is equal to 1. Understand?
okay,
Okay.
1, okay.
So now the next problem is so consider the equivalent domain Zi, and here there is 5 plus 5 is equal to a into 2 minus I plus r. Now the question is what is a and what is r? So first answer is a is equal to 1 plus 3i not equal to 0. A is equal to, I mean, so there is no point of giving these options. So tell so tell what will be a and what will be r. There is no point of giving the options. Okay. Can you please try how to get the small a and small r? I mean, it is the problem. Please tell. I mean, So first tell me how you will solve this. First tell me how you will solve this. I mean it's a basic problem. So how will you solve it? 5 plus 5i can be written as this as per your problem. It is I'm writing this. So this is equal to 2a minus ai plus r. Okay. Now a and r also belongs to Zi. So we can write a is equal to a1 plus ib1, r is equal to r1 plus I. So just substitute a1 plus ib1 minus a1 plus ib1 I plus r1 plus I. Now do the substitution and do the real and real part complexes separate. You will get the answer. Okay. Eventually you get the answer. So there is nothing really. I mean, do you understand? Do you understand? Please don't be silent.
Yes, yes.
So, okay. So in the ring set, uh, consider the ideal generated by 6 and 15. And since there is a PID, so it can also be generated by single element. Now the question is, what is the value of it? So repeat the question. Consider the ring of integer Z. Okay. Here consider two ideals generated by 6 and 15. Okay. So but now since Z is a PID, so this ideal can also be generated by single element, right? Call it small a. Now question is, what is the value of small a? Determine the small a. Think about it. Each of the fellow who are in this live session, please try. If you have any problem, please ask. But please don't be silent because this live session is meant only for problem solving. So please don't be silent. So anybody please get the answer or any idea how to get? If you have any rough idea, please tell. So the thing is, in this ideal, okay, so let's be clear. 0 by 6 and 15. What are the how the element look like? 6n plus 15m, right? Correct. Now, so we can get 3 common, 2n plus 5m. Right. So this belongs to ideal generated by 3. Right. Moreover, take any element in ideal generated by 3, then it can is 3 into z. Right. So now, I mean, so thing is that now 3 can written as uh, 15 minus 6 into 2 whole into n. Okay, so this can be written as 15n minus 6 into 2n. So this belongs to ideal generated by 6 more 15. So that's why ideal generated by 3 is equal to ideal generated by 6 more 15. So in general, the fact is as follows, that ideal generated by Mn is equal to ideal generated by its GCD. That's the fact. Okay, do note one thing, that here 6 and 15 GCD is 3. That's why here it is answer. Ideal generated by 3. Okay, so that's the fact. So yeah, so that's what. So do you understand? Yeah? Okay, I hope so. Okay, just let me tell one thing there. Uh, and don't write, don't reply one minute. Just hold. I will get the couple of minutes. Okay, so don't usually write over chat, okay, because uh, while writing over the screen, I can't see chat. So can please unmute yourself and tell what you wish to do. Okay, so okay, so okay, so go to the next problem here. One second. Mm, okay, so the question, next question is as follows: that in the ring of integer z, in the ring z, let J1 be ideal generated by 3, J2 be ideal generated 4, then J1, J2 is given to be ideal generated by 8. Now determine what is value of small a. This is the question. So in the ring of integer z, we have two ideals z1 z2. Z1 is J1 is generated by 3, J2 is generated by 4. Now determine what is J1 dot J2. I mean J1 multiplied by J. I mean J1 J2 is ideal generated by A. That's obvious because it's a PID. But you need to determine what is the value of small. That's all. Okay.
And how J1 J2 is defined? This is the collection of finite sum, a
Right.
product of. Okay, okay.
Correct. So any guess what will be the value of small a?
1 minute, sir. 12. Is it 12?
Yes, correct. I mean, yes, yes, it's obvious. Just multiply. That's all. That's the thing. Nothing more than that. Okay. 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 So first, tell me, do you know the Noetherian ring? What does it mean?
No, hearing, no. I don't know.
Okay. So first define a ring R is said to be Noetherian if every ideal is finitely generated. Okay. So that is one definition, and equivalently, every ascending, sorry, let me write clearly, every ascending chain of ideals stabilize. That is, if you have any increasing chain of ideals, then it stabilizes means there is some k such that I small k is equal to I n for all n greater than equal to k. Okay. So these are the two definitions, two equivalent condition of Noetherian. The first one is every ideal is finally generated. Second one is every ascending chain of ideals stabilized. Now you may think that why two definitions. The thing is that I mean we may need to use different definition, different situation. That's why two definitions. There you need to remember these two definitions. Okay. So for example, if you consider Z, so in there is a
One
T.
minute, sir.
Yes.
Excuse me. Every ascending chain of ideals, which is the
Stabilize.
word stabilize.
Yes. Yes.
What is the mean?
Means it will stop. I mean, so that's what it. I1 contains I2 contains I3 dot dot dot. If it is ascending chain, increasing chain of ideals, then
Mm,
we will get a case as Ik equal to In for all and greater than equal to k. That is after certain steps,
mm.
it will not increase. It will stabilize. That's the meaning.
Okay. Mm, okay. Now have to check whether these conditions are equivalent.
Uh, yeah, these are the equivalent statements.
Okay. Okay.
Okay. So either the first definition or the second definition solve the following problem. What is the true false problem? A surjective homomorphism, obviously ring homomorphism, okay? F from A to N. The question is that surjective homomorphism Fa to A of a Noetherian ring A is an isomorphism. It is true or false? That's the question. Okay, for the time being, sorry, for the time being, skip this question because uh, the counter example that is needed is not right now in our scope. Okay, so so kindly skip this question for this time being because first us need to go through some yeah. I mean, there's a theorem that if R is an isomorphic ring, the R is an isomorphic ring. Using that theorem, then only we can give a counter example of this question. Okay, so kindly skip this problem.
This is answer is false. Okay.
Why?
Uh, I am asking. I'm not. Yes.
Oh, okay, okay, yes. Obvious answer is false.
Okay.
Okay, so so let's go with the good theory problems now. So Suppose x, y, z are elements of a group G, such that x square is equal to y is the identity, and and y and yz equal to z square. Okay. Now the question is, which one following control? First is x y is equal to y. Second is y z is equal to z y. Third is z is equal to x z. Fourth is z is equal to. So given x, y, z three elements of a group G, and such that x square equal to y square identity and y z equal to z x y. Okay. Now we have four relations. Now we need to determine which one is true. Think about it and let me know the answer. This is the problem. Okay, please think about this. I will get back after some time. Sorry. Okay, so anybody solve it?
Hmm.
So okay, so how you will get this? Sorry, I also don't know what exactly. Let me calculate first. So given relation of y z equal to square n x square equal to y square. Okay, so from right and left multiply x y step x step x y. Okay. Uh, okay, no, first multiply y. So y square identity, so z equal to y z x y. Okay. Now yz is going to be z x y x y. Okay. So this implies x y whole square will identity. X y will identity. Okay. So this implies x y is equal to x y inverse. This implies y inverse x inverse. So y x. Okay. So x y equal to y. This is one relation again. So you tell me the option 2 is correct, right? Okay, so how you are getting the option 2? Just tell how you are getting the option 2. Please don't be silent. Tell how you are getting the option 2. Okay, so the thing is, since I am getting option 1, so I mean, okay, if option 2, then okay, yeah, option 2 maybe come from some other calculation. So let's not get into this. So, the question is find the number of generators in the group Z2, Z2, Z2. Find the number of generators in the group Z2, Z1, Z2, Z1, Z2. Please tell how we will do this. Okay, so the thing is that Z2 is generated by 1, right? So Z2 direct from Z2 direct from Z2 is generated by 1 0 0 0 1 0 0 0 1. So it has total 3 number of generators. So yeah, so it has three, it has 3 generators. That's it. So there is one problem for the assignment. This is that, I mean, every problem is assignment. This is a number 5 problem with 3 chords. A is 1 comma 2 3 comma 4, okay, and B is 2 4. So everything is element of symmetric group, and G is a subgroup generated by A and B. Then G is isomorphic to what? First option is dihedral group order 4. Second option is dihedral group order 8. Third option is symmetric group. Fourth option is A4. Okay, so think about the answer. A is 1 comma 2 and composed 3 comma 4. B is the cycle 2 comma 3. Everything is an element of S. So G is the subgroup of S. So generated by A comma B. Now then G is isomorphic to D4 or D8 or S3 or A4. Okay, that's a thing you need to check. Think about it. Whatever you're getting or whatever your idea, yes, please tell. Don't be silent. Also, one thing is that over the chat, I've shared a one Google form link. Kindly submit the Google form now to record your attendance. Kindly submit the Google form in order to record attendance. So from the chat, I don't know whether I'm audible or not. Okay, so can you please tell whether I'm audible? Am I audible?
Yes, audible.
Okay, so now, okay, so solve this problem. Learners kindly submit the attendance to Google Form.
D4.
Why?
Order of A is 4. Order
What?
B is 2.
No, wait, what is the order of n? You say?
4.
No, why it is 4? Order of sigma 1 composed sigma 2 is LCM of order of sigma 1, order of sigma 2. So order of A is itself 2,
Okay, sorry, sir. 2.
and order of B is equal to 2. Then then what is the argument? Anyway, so you can check one thing is that AB is equal to B. Yes. Okay. So basically G is nothing but generated by A and B, such that A square equal to B square and AB is equal to B inverse. That's why G is isomorphic. It's the same presentation with diagonal waterfall. That's why it is isomorphic to diagonal waterfall. That's all. Okay. I mean that's the argument. Okay. Everybody who till now did not submit the attendance, please reach your attendance. The submit Google form. Okay. Okay. For now, that's all. Uh, if you have any doubts or any questions, please ask. Also, for those who did not submit the attendance, please give your attendance. If for any doubt, any questions, please ask. And in the next live session, we shall first with the rest of the assignments. Today we have gone through assignment 6 and partial assignment 5. Okay. And next live session, we will have rest of the assignments. Okay. And if you have any doubt, you can email me. I will reply you. That's all. And those who did not submit that until now, please submit that in a Google consultation. Okay. So for today, that's all. I am ending the call right now.